Hello, my name is Derek from Tomcat Gas Training and welcome to episode 3 of how to use a flue gas analyzer and understand its results. Now if this is the first video you're watching, you've started at the wrong place because there's 2 videos before this one. So, first video was how to flue gas analyze boilers. The second video was how to flue gas analyze flueless space heaters and cookers. So if you've not seen those 2 videos yet, then check over there and get them looked at. But if this is the third video you're watching, thanks for tuning in and get ready for episode 3. So as usual, let's just get on with it. Now before we continue on how to actually flue gas analyze other appliances, I just want to spend a bit of time talking about looking after your analyzers. It'll cost a lot of money, so get looking after them. So, we've got 2 analyzers here. This is the TPI DC710. This is reasonably new onto the market, and so is this one. This is the Ariston Sprint Pro. But the big difference you can see in these analyzers is that one's got a screen, that one hasn't got a screen. Okay, this one uses your mobile phone as a screen rather than actually built into the analyzer. So this one should be, I don't know what it is, it should be a little bit more robust than this one. And if you haven't seen our video on which flue gas analyzer is the best, then check out those because you'll see exactly how robust this is because I drop it. What we're going to be dropping is the Ariston. I've got the pump running, so we know it's running and it's not some kind of effect. So I'm going to hold it at the top of this stick, which is 1.8 meters off the floor, which is the average height of if it dropped off a boiler. So here it goes. Let's see if it works. Not looking forward to this. So we're on the top. Anyway, I am going to be doing a full review on this analyzer soon. So check that out soon. So, because this one's got a screen, we need to be extra careful with it, that we don't drop it, we don't get water on it, we don't damage it. Okay, like I say, because this one hasn't got a screen, we still need to be very, very careful with them. Now, the other thing what happens a lot with analyzers is when guys are turning them off. So basically what they do is they turn them off and put them in the bag while their pump's running. Now, if you do that with this one, it doesn't really become a problem because we've now got this big gap at the bottom now, so it won't suck all the rubbish out the bottom of your bags. Okay, this one is kind of semi-recessed as well, so this again probably wouldn't suck any rubbish up. So be careful when you're putting them in the bags. Make sure they're turned off first before you do that, because you don't want to be damaging the pump by sucking debris out of your bag. Bits of wire wool out the bottom of your bag. So turning them off can even be dangerous. So just watch out for that. And again, keep them in your bag at all times when you're not using them. And definitely don't leave them in the back of your van, especially this time of the year in winter. The inside of the analyzers can actually freeze and damage them, so you don't want to be leaving them in the back of your van, and also the massive theft we have for flue gas analyzers. So keep them with you at all times, okay? Like I say, they're incredibly expensive and you don't want to get them nicked, okay? And you definitely don't want to be sending them back to be repaired because 1, it sucked a load of rubbish up out the bottom of your bag, or 2, it's frozen in the back of your van, okay? So that's the first thing, the units themselves, look after them. They put rubber boots on them and stuff like that to make them a little bit more robust, but you know, be very careful. Now, the bowls. So we've got 2 different types of bowls with 2 different types of filters in them. Now this is the brand new Ariston. And again, if you see our video on which flue gas analyzer is the best between the Kane, Blue Laser and Ariston, you'll see I'll go into this in quite detail. Now in this one, we have a sponge filter. Okay, we've also got a PTFE filter inside here. okay, which stops water getting past it. Now this has got quite a bit of water in it. Well, it's not got it's moist, and this sponge needs drying out because it's not got a lot of water in it, but I can feel the moisture. Now the reason why this needs to be dry is because when the filters are wet, they attract CO, carbon monoxide, to them, and it can saturate the filter with carbon monoxide, which will give you false readings. So the first thing is you've got to make sure your filters are dry. Now with this one, you can just stick it on the radiator, okay, and it can you can dry it out that way. This, you can just blow it through, but water shouldn't get past that filter, okay. So that is your last line of defense, okay. So that's the first thing. Now the next thing is make sure the bowls are dry, okay. So you don't want to be collecting water in here. This is here to protect the analyzer, okay. So like I say in the beginning of the video, sticking this probe actually into the boiler is one of the biggest problems engineers do. They stick it in too far. So if you're sampling from inside the boiler, don't go more than 150, especially on the Worcesters, okay? Because a Worcester allows you, because it's in the flue elbow, a long way to go into the flue products. Whereas if you get the boilers where the sample point is at the beginning of the turret, you're less likely of sucking that water in because you can't put the probe in all the way. It'll only go in about 150 on your sample point. So boilers like Ariston, Valent, they have sample points at the top of the turret. Bax's, they're another one who have them. But companies like Ideal, Worcester, who put their sample points in the flue elbow, that can cause problems by you sliding it in too far, okay? And that's where you're getting the water from, remember? From your flue. So make sure every night, you know, give it a bit of TLC, okay? Treat it like a lady. Take it out, wine and dine it, give it a good cleaning, okay? And then make sure when you're putting it back together, you put it back correctly, okay? And after you have taken it apart, test it. Because one thing we don't want to do is get air getting into our sampling, especially when we're doing flue integrity testing, because it can actually give us the false readings. So always read and understand your manufacturer's instructions about the maintenance of the bowl. Now in this TPI filter, there is like a paper filter, okay. So the first thing is we've got to undo the filter. But it's got the same kind of PTFE filter. To me, it looks exactly the same. Okay, so again, this will stop water ingress going in, but it has a paper filter. Okay, and this has got to be changed on a regular basis. This looks actually a bit tatty, but if it just gets wet and it's not damaged or dirty, and then you could actually dry it out on a radiator overnight. Okay, so once you've cleaned your bowl out, you could actually dry that out. Okay, so remember, you need to give them TLC. Let's say, treat them like a lady, or treat them like your fella. Treat it like something that's really precious to you, like your husband, your wife, your boyfriend, your girlfriend, your dog, your cat. Okay, treat it really carefully. And don't forget to put your PTFE filter back in. Okay. If it falls out and you can't remember which way it goes, you can always look in manufacturer's instructions, but just a rough guide. The pointy end goes towards the analyzer. I don't think you can actually put it in the wrong way. You can. But the pointy end does go into that way, and then line it up with the two little lugs. And then twist it on, and then that should be airtight now. Okay, I remember the test I did in episode 2 on blocking up the probe and seeing if it actually puts an alarm up. this does exactly the same. Another thing what TPI have on their analyzers is this other little filter thing here where the analyzer, where's the end of the analyzer? Oh, looking at me. The analyzer actually plugs into there, so you've got another line of defense. Okay, they obviously put these into the analyzers because we don't look after them. Okay, so just remember guys, this bowl isn't supposed to completely fill up with water. Okay, you're supposed to drain them all the time, you're supposed to keep them clean, you're supposed to stop the water getting in there. Okay, so the bowls, incredibly important. Make sure they're dry, make sure you change the filters on a regular basis, and if, like I say, if the filters aren't damaged, just dry them out on the radiator. So that's the bowls. Now let's have a look at the actual probes themselves. Now this is the most important thing about the probe, the stop. Okay, if your stop's missing, your analyzer's useless. Your stop is there to restrict any air getting in and giving you false readings. Okay, it also helps you as a depth gauge. So this is incredibly important, this little cone. Okay, now hopefully it doesn't fall off the end. So what they've done here is just splayed the little end over a little bit, so, well, splayed it out so it doesn't fall off the end. Okay, so if it does fall off the end, like this one, okay, you can lose it. Okay, and if you've lost it, it's useless. Same for the screw as well, you don't want to be losing the screw neither, because it's important that we're stopping air ingress. Okay, the other thing is the handle split, is there any breaks in the hoses, and again, like I say in episode 2, we could, you know, we need to do the test on a regular basis to make sure we aren't getting any air ingress. And this one as well, you could actually, when the pump's running, you could actually bend it over. In the manufacturer's instructions for this TPI, they actually say pinch this because it's incredibly soft. Okay, and the pump should stop and put an alarm on. Okay, but not every analyzer does that. You need to read the manufacturer's instructions, but you need to make sure there is no air ingress. So that's looking after your analyzer. Because if you look after your analyzer will look after you. And remember, it's just 5 minutes little TLC every now and again, just to look after it, and just don't abuse it, because if you abuse it, you're going to break it, and if you break it, you're out of work. Okay, so that's a look at looking after your analyzer. I hope that helps. So let's finish off and look at a few other appliances and how we analyse them. Now, when you're flue gas analysing an open fluid appliance, we can't be going drilling holes in the top of the flue and putting our probe in there. Oh no, because you just made the flue ID, the products of combustion are coming out, because you've just broken the integrity of the flue. So you do not drill holes in this flue, okay? And if there is a hole in the flue, someone's put some tape over it, because it should be twin wall flue system coming off the top of an open flue boiler. This is a training centre, this is the wrong flue system. So if you've got single wall, that makes it at risk. And if you've got damaged flue with a hole in it, it's at risk. And if products of combustion are coming out of it, it's ID, okay? So never drill a hole in the flue for a flue gas analyzer test port, because what you're supposed to do is take your probe, and you can actually get some extension pieces. I have got an extension piece here, or you can have it made, but you have to slide it up the flue, and so you're inside here and you're sampling up the back of the draft diverter. Okay, so you come in at the back of the draft diverter, find the flue hole. There you go, I'm in. So I'm now in the flue ways, and it says to be about 100 mil into the flue way. Okay, and my hand is still down at the bottom. So if this was in a compartment, you would have to have the door of the compartment shut as well when you're flue gas analysing it. Okay, so open fluid appliances, you'll be flue gas analysing this on maximum, because there ain't no minimum setting. and you'll be looking for a ratio of less than 0.008. And if you didn't get that, you'll be at risking it, stripping it, cleaning it, whatever we would need to do to get that ratio down. But the main problems we find with oven flue appliances, people drill holes into the flue system to take the sample. No, up the back of the draft diverter. Let's have a look at fires. Now, when we come to a radiant fire to flue gas analyse, there's nowhere to do it. Okay, so we can't flue gas analyse a radiant fire unless you're going to get on the roof and do it from the chimney, because there's no way of getting a probe inside. These weren't designed for flue gas analysing. But sweep testing, we should still be sweep testing around the appliance. Remember, 100 mil away from the appliance and sweeping around the appliance for that 2-minute test. Also, the open fluid boiler behind me, sweep test on that as well, taking in particular care around the draft diverter. So it says sweep around the bottom of the draft diverter, okay, and around any seals where you would take away, you would remove for servicing. So this fire, no flue gas analysing on this one, but we can do the sweep test. So let's have a look at an inset live fuel effect. When you're flue gas analysing the inset live fuel effect fire, it says to put the probe into the flue this way. Obviously the fire needs to be running. I'm not putting the fire on because I've been burning my hand, but you need again the extension probe to be able to be like here, but you have to get right in 100 mil through the spigot hole at the back here, so underneath there, so it needs to go right the way in. So obviously I'll be getting burnt now if I have this on. So again, you need the extension probe to be able to analyse this fire. Now the ratios we're looking for this fire is 0.02, or unless the manufacturers give you an actual reading, which I doubt because they weren't made for analysing. So that's what we're looking for, 0.02, and that's your CO-CO2 ratio. But again, sweep test afterwards, it says 100 mil in front of the fire. Okay, so that's flue gas analysing the inset live fuel effect fire. Now I just want to cover this last bit of thing on ratios. So this is the CO-CO2 ratios for natural gas. LPG is slightly different. So if we have this maximum CO of 350 ppm, the lowest reading CO2 we can get is 9, because if we get less than 9, we're going to go over the 0.004. So we've got 350 divided by 9 divided by 10,000 gives us a ratio of 0.0038. So that's the lowest CO2 reading you can get. Okay, if you got 8, you would be going way over the 4. Okay, now if we had 100, which is probably average of what we're getting. Okay, so we've got 100 CO, but we're only getting 3.3 CO2, okay, then that's the lowest CO2 we can get on 100, because 100 divided by 3.3 divided by 10,000 is 0.0030. So that's the lowest we can go for our CO2 reading with a CO of 100. So that gives you some idea of, when we're looking at our ratios, what we're looking at, what we're understanding. Okay, now we're going to look at how to alter the ratio on a zero governor to finish off with this video. Now when you're adjusting a zero governor valve, you're doing it to manufacturer's instructions to start off with. There are some other, there's a technical bulletin 013 I think on GasSafe. We'll also tell you about altering zero governors and the different types, but you must follow the manufacturer's instructions. And if the manufacturer says do not adjust the zero governor, you do not adjust it unless we're changing it from natural gas to LPG, okay, or LPG to natural gas. But before we start going in there and adjusting the valve, when we're doing a service, we need to make sure we've done a full strip down service and we've covered all bases before we start adjusting this valve, because you can turn the burner into a flame-throwing furnace and start melting the aluminium door on the 360 degree burners, okay, or damaging the heat exchanger, melting the sump on a downward burner, okay. So make sure it's the last port of call, because they don't often go wrong, okay. It's normally they're broken if you're getting funny results or something else has happened. So it's the last thing you ever do is altering the CO2 levels on a zero governor, okay. So let's have a look at that now. Now this is the boiler we're going to be changing the zero governor. This is the Ariston ecombi 1. Okay. Now first thing I've done is I've got my TPI SP620 manometer connected, and it's connected to my iPad. So it's showing our pressure at the moment is 23.25 millibars. That's on the inlet test point. Okay. So I'm going to be checking to see whether I'm getting the right pressures when I've actually got this on maximum reading. So that's going to be checking that while we're doing it. Now according to Ariston, we're allowed an inlet pressure of 17.5 millibars. Okay, so we've got the gas meter on, we've got this connected, and when we put it in high fire we're going to make sure we've got readings more than 17.5. So first thing I need to do is remove the test point. So I've removed the test point off the top now. Next thing I need to do is get the analyzer turned on in fresh air. Now the analyzer is turned on and you can see it's reading 20.9 and everything else is 0. So I know this is ready to go. Now first thing I need to do is I need to get this boiler on, and I need to put it in high mode on this boiler, so high and low. So we're going to check the CO2, the ratio in high and low, and adjust it if we need to. Now, this boiler has a sit gas valve, okay? So it has two connections on the gas valve. It has what's called an offset, which is here. So this big one here is the offset. And it also has a throttle. Now the big one here, the offset, adjusts the minimum setting, and the throttle adjusts the maximum setting. So what it's doing is it's adjusting the gas flow basically. So what I'm going to do now is I need to turn this boiler on and leave it running for a little while. It has been running for quite a bit today, so I've just turned it off so I can do this. So basically I'm going to turn it on first. I'm going to hold the reset button. So test mode comes up, then I'm going to press my plus button, and now this should go in high setting. Okay, so the boiler is now lit, it's now gone in high setting. So, like I say, my Pro 150 point, okay? And that's now going to sample. Now I need to get a steady reading. If I don't get a steady reading, I won't be able to adjust this, okay? So at the moment I've got a CO of 29, CO2 of 75 and a ratio of 0.0005. So with my digital manometer connected, I've got an inlet working pressure of 19.98 millibars. This manometer is amazing, okay? This has been loaned to us by TPI, so I'm going to be doing a full video on it, so we'll talk about that later. But what a great gadget, as long as you've got an iPad. You could actually use it on your phone, but I'm using my phone for filming, so as well as doing other stuff. So at the moment that's what it's showing, plus it's got this big screen, so hopefully you can see that. So we've got 19.95, we've got it on maximum. So that's the first thumbs up. We've got more than 17.5 millibars. So that's a good start. Now our settings, we have an O2 of 5.7, a CO of 59, a CO2 of 8.6, and a ratio of 0.0007. Okay. Now, on maximum settings, the manufacturer says we can have between 8.7 and 9.7 on the CO2. And at the moment, we've got bang on 8.7. Okay. Now, some manufacturers will tell you to adjust the minimum first, and some tell you to adjust the maximum first. But you should always follow your manufacturer's instructions. Now, on the Ariston manufacturer's instructions, it puts the maximum first in the book, but doesn't actually tell you to do the maximum or minimum first. But anyway, some of the manufacturers do. So we require one of these. Okay. So basically, we've got an Allen key. Okay. So on this side here, we've got a 2.5mm Allen key, and on this side here, we've got a 4mm Allen key. Okay. Now we're going to be adjusting the throttle. Now, if I want to increase my CO2 reading, I need to turn it anti-clockwise, and if I want to decrease it, I want to turn it clockwise. Okay, but again, check the manufacturer's instructions. So at the moment, I've got a CO2 of 8.7. If I go onto the throttle, I put in my smaller Allen key in, if I can see it. Okay, I now want to increase it. So I'm going to increase it by turning it anti-clockwise. So I'm just going to turn it anti-clockwise now, and I'm making small adjustments. So I've got to make small adjustments, and I've got to wait. The manufacturer says a minute, but remember it takes 10 seconds for it to come from the probe into the analyzer. So they say wait a minute. So I've just made a tiny little movement to the anti-clockwise, and it's now gone up to 9.1. Okay. So what I'm going to do is I'm going to make a little adjustment back again and get it back to 8.7 or around about that. So it's just a little movement, a little twist, and now I've got to wait now and see what it's going to do. So again, got to wait that. It says wait a minute. So it's now gone down to 9 from 9.1. Again, I'm going to try and get it back to the 8.7. We're still on, oh no, we've gone down to 8.8. Now what it says is a little full turn going all the way around will adjust it about 0.2% on the CO2. But I'm doing little tiny turns. Okay, we're on 8.8, I need to make that little adjustment again. So hopefully now this will be back to 8.7. But I could have actually left it where it was at 8.8. 8.7 to 9.7 we've got on maximum. So it's on 8.8. Okay, so I'm going to leave it there. So now what we've got is we've got an O2 of 54, we've got a CO of 66, and we've got a CO2 of 8.8 with a ratio of 0.008. So that's our maximum adjustments. Now on our inlet pressure, we got 21, oh well 20.1 millibars, so that's perfect. Okay, now you must be checking your inlet pressures as well while you're doing this. So we've got perfect inlet pressure, and we've got the readings we require on maximum. Okay, so now I'm going to put it on minimum and have a look at those readings. Now this time we're going to do the actual offset, so I need to take off the dust cover first. So there's a little chrome dust cover on here, and again we're using the 4mm Allen key. Now this is the opposite way to the last one, so if I want to increase it, I have to turn it clockwise, and if I want to decrease it, I turn it anti-clockwise. Now for this one, for minimum, we're looking at 8.4 to 9.4. Okay, so that's your CO2. Now we've got at the moment 8.9. Okay, we've got a CO of 5 and a ratio of 0.0001. So again on minimum, we've got an O2 of 5.6, a CO of 4, a CO2 of 8.7 and 0 ratio. So those readings, according to the manufacturer again, are perfect, okay? But if I wanted to reduce it a little bit, I could put my Allen key in and twist it a tiny little bit. Let's see what that does. So I have turned it anti-clockwise, so it should decrease it from 8.9. Okay. Now remember, this is for natural gas. If I was doing this for LPG, I would have to set the valve up for LPG. It would be completely different. Okay, so always read the manufacturer's instructions. So it's now gone down to 8.8. Okay, so I'll go back up to 8.9. So we've got an O2 of 5.4, a CO of 4, a CO2 of 8.8 to 8.9, it keeps flickering, and our inlet pressure, we've got 22.45. So it is actually on, but it's on minimum. So everything seems to be ticky to boo at the moment, but I'll just adjust that a little bit. Tiny little turn. Now it's gone down to 8.8. Now remember, the manufacturer says wait a minute, but again it takes 10 seconds to get down there. Okay, so we could actually go down to 8.4. So I'm going to give it a bit of a twist. So we're down to 8.7 now. So we've got, so again on minimum, we've got an O2 of 5.6, a CO of 4, a CO2 of 8.7 and 0 ratio. So that's our minimum, but now, because we've adjusted the minimum, we need to now check it back in maximum again. Okay, so let's see what's happened in the maximum reading. So I'm going to put this back in maximum. And let's see what the readings come out for that. Now again, I need it to stabilise. So at the moment we're on maximum setting for the second time, checking that. We've got a O2 of 5.5, we've got a CO of 53, we've got a CO2 back to the 8.8 what we had before, and we've got a ratio of 0.0006. Okay, so it looks like everything stayed pretty much the same. Remember, we've got this 8.7 to 9.7 for the CO2 on maximum. We've got a pretty low CO, haven't we, of only 52. So, crank it back up to 9 if I wanted to. But that gives you some idea now of how we're adjusting it and how long it takes to adjust it. Our inlet pressure, we've got this on maximum and our inlet pressure is 20.11. Okay, so we know that's fine. We know now our target pressures are working fine. We know now our flue gas analysing is at the moment coming in now at O2 of 5.5, we've got a CO of 53, we've got a CO2 of 8.8 and we've got a ratio of 0.0006. So those figures are bringing us well in. So let's just change it again now to minimum and see if that's changed. So I'll just put it back onto minimum setting again. So we're now back in minimum setting. We're now getting a reading back on the screen. We've got, so our final low reading is O2 of 5.8, a CO of 5, a CO2 of 8.6, and a ratio of 0.000. Now not. That's our minimum setting. So that's adjusting a zero governor. Now that is the end of this video on flue gas analyzers, how to use them and how to understand the results. Now if you've liked this video, why don't you give us a thumbs up, because it shows me you care. Or why don't you hit that notification bell and subscribe if you haven't subscribed, because we release videos every Wednesday. So thanks for listening, thanks for watching, and if you want to watch any of the other videos, why don't you click on the links above. Cheers guys!